All right. Hi, everyone. Welcome to the Ravit Show. Happy Tuesday. I'm super excited for today's show as we have not one but two exceptional guests, Sanjeev Mohan, the principal at SanjMo, and ex-former analyst at Gartner, and none other than Egor, co-founder and CTO at Bigeye. We'll be discussing about data observability, data ops, data warehouse. Maybe we'll also get into the present and future of data observability. So, looking forward to hearing from two experts. We are open to questions, insights, and anything you might have for Igor and Sanjeev. So, don't hesitate asking those questions. Get those running by us. We are also giving away one swag by Bigeye. So, what you just need to do is type in hashtag Bigeye in the chat, and here we go. This is what you need to type, and you'll enter the raffle. By towards the end of the show, obviously, we'll be announcing the winner for the raffle. Okay, just a little about our guest. Sanjeev Mohan is an established thought leader in the areas of cloud, big data, and analytics. He researches and advises on changing trends, technologies, and the modern data architectures. Until recently, he was a Gartner vice president, known as his prolific and detailed research for directing the data analytics agenda. A little about Igor. Like I mentioned, he's the co-founder and CTO at Bigeye. Before starting Bigeye, Igor was a staff engineer at Uber, where he scaled the company's first data warehouse, supporting thousands of internal users and mission critical workloads. Can't wait to hear from both of them. So let's get both of them up here. Hey, Igor. Hey, Sanjeev, welcome to the Ravit Show.
Thank you. Thanks for having me.
Hey, Ravit, thanks for having us.
It's such a pleasure to have you back, Igor, obviously, because you share a lot around data observability and we can't wait to hear more things. But obviously, it's a pleasure to have you here, Sanjeev, because we've been hearing a lot from you around data observability, but not only just that, around data, about big data. So we would love to hear your thoughts. But why not go out with your introductions and then we can get into the weeds. Maybe, Igor, you can go first.
Sure, and you've done a great job of introducing myself, but I'm Igor. I am the co-founder and CTO here at Bigeye. I am a data nerd at heart. I've done software for my whole career, but I've always done software in service of data and analytics of some sort. Everything from Hadoop to data warehousing and BI and analytics and ETL, SQL, whatever, anything data related, I have probably touched it at some point in time. And building data tools is really my passion. I've done it internally at Uber and started Bigeye as a way to bring a lot of these best practices and the knowledge that we've built up over time to the rest of the market. So very excited to be here.
Okay, this is fantastic. Sanjeev?
Thank you, Ravit. So I also have to say that I'm also not a data nerd, a data geek. And if you're wondering, like, what's the difference? Data geeks and data nerds are almost the same. Data nerds are just socially awkward.
This is why you're the analyst, Sanjeev.
I said that at a conference, and somebody said, "Is there going to be a Gartner Magic Quadrant on this topic?" So, yeah. So, I'm very happy to be on this call. I was in Gartner for almost 5 years, part of the data and analytics team. Had a great time there. Researched, learned a lot, wrote a lot of documents while I was there. But now, since 1 year, I decided to go independent because I just wanted to explore more avenues, expand my research area into some new topics that are not that were not yet well defined. Data observability was one of them. I was already talking to Igor, so he had introduced me to this concept. But I've done my own research since then and learned from the industry. And now data ops, data observability are two of my favorite topics.
Okay, that's pretty cool. And Sanjeev, I like the title Data Geek. It obviously brings a lot out there when you become a data geek. But since you both come, from a data background, and obviously data engineering as a space has been, obviously evolved a lot. I would actually love to hear from you both. How do you look at it since last few years, and obviously how do you see it in the future as well?
Yeah, I'd be happy to start. So data engineering is following a really interesting path right now in terms of scale, both in terms of volume of data, but also in terms of complexity of use cases and the heterogeneity of the data and the use cases at the same time. So if you think back to, I mean, we can look back a little bit more than a few years, but before data warehouses were on-prem, you usually had to usually started by syncing your own internal data into these warehouses, and you had your application data. You did some product analytics and performance analytics. Then slowly things started moving in the other direction, where you started bringing in data from the outside the business, from marketing, from sales, from click tracking on your website, whatever it is, maybe even third-party data that you're buying from other services in order to enrich the information you have internally and make some business decisions. And over time, data engineering has changed because you now have to deal with all of these complexities. You don't just have to understand your own company's data, but you also have to understand where is all the external data coming from? How does it join in? How do you model that so that it actually makes sense? And so this is a much more difficult job than it was 5 years ago. And this is really why you're seeing all this proliferation of data tooling to help you with the modeling. We're talking about things like semantic layer is very popular right now. Metric layer, semantic layer, these notions of how do you canonize information around the business when the information is all over the place and has different definitions everywhere else. And so that there's tooling around that. There's tooling around data observability and data quality, because now it's not just about what you know about your data, it's about what is expected of data that you do not control. There's data catalogs are becoming exceptionally popular now for the same reason. You have so much more data and so much more diversity in it that you need to be able to control that at scale. And not at the scale of hiring more people, but at the scale of how do you make the people more efficient? How do you give autonomy to your data users? And I hate to use a buzzword here, but how do you democratize data within your organization by giving people the tools that they need? And so that's where I think data engineering has really gone in the last few years. And moving forward, it's only going to get worse from a complexity perspective, because there's always new sources, there's always more information, there's always more decisions to be made. I think the next big leap is going to be the performance and efficiency standpoint, because now that we can get all this data in one place, now we're starting to see all of these discussions around, well, okay, what costs more, Snowflake or Databricks or BigQuery? And previously, when the focus was around get things in, do something with it, let's just get more things into one place, run more queries, run more ETL, do more modeling. Now it's a question of, all right, well, now we're running 100 pipelines, but people only look at 10 tables on a weekly basis. Do we need to run 100 pipelines? Should we run them less frequently? What size is our warehouse? Do we need to run an extra large Snowflake warehouse, or can we suffice on a medium and save ourselves money that way? I think cost and efficiency is that next hurdle that data engineering is going to overcome, in the same way that software engineering had to overcome it when they went to the cloud, when they started running applications on AWS and they said, great, we can auto scale it. And then it auto scales to a $100,000 a month bill, and nobody expects that. So that same hurdle is coming for data engineering. And I think that's going to be the focus in the next year or two for a lot of teams.
Pretty interesting insights. What do you think about it, Sanjeev?
So Egor's answer is right on the dot, and he's covered a vast space. So if I were to add a few more things to what he said, so one change that I see why data engineering is so hot is because we are now focused on building data products. And data products are basically adding more product management discipline into how we build data outcomes. But the outcomes are the same. It could be a table, a report, a dashboard, a machine learning model, but with that product management discipline. So that's a data product. So that's one. The other thing that is happening is, and Igor mentioned this, that we have more data sources. So we are creating these pipelines, and literally organizations today are running thousands of pipelines at all various times. So they run at different durations, for different lengths of time. They are built by data engineers that may be geographically distributed. So, and they use their own tools. And who are they serving? The data consumers. And the data consumers are no longer just, a few, subject matter experts running reports or dashboards, but there could be thousands, tens of thousands of consumers. When you multiplex all this, you got multiple data sources, multiple pipelines, multiple consumers, multiple tools, geographically distributed. Something is going to break. And
Right.
like, Werner Vogels has said at reInvent, CTO of Amazon.com, everything breaks all the time, especially at that scale when you talk about thousands. So that's why, and I completely agree with Igor, that's why this space is going to get even more complex. And
Right.
that's a world we live in.
Okay, those are great insights, Sanjeev, definitely, and thanks for sharing that. And today, obviously, when we talk about data engineering, the most important and the most hot thing that comes out is data observability, and people are knowing the importance of data observability out there and wanting to learn more about it. But observability isn't a new topic, and has been relevant in apps and infrastructure since a while now. So how do you think, how is data observability different? What are your thoughts around that? Maybe Sanjeev?
Yeah,
Yeah.
so basically, by explaining how data engineering has changed, I laid the groundwork of why observability is needed, because I
Mm,
painted this big picture of how complex this is. You're absolutely right. Observability is not a new topic. We've been doing this in applications. We used to call it APM, or we still call it application performance management,
right.
infrastructure. So companies like Splunk, Datadog, and there's so many of them. They've been around for a very long time. Uh, by very long time, it's all relative. We're only talking about last 10 to 12 years. But the
Mm,
point is that we used to look at infrastructure level metrics like packets, firewall, SIEM, SEM tools, and things like that. But it's more important to look at data. In fact, I would even say that uh, observability is actually not as important as it used to be, because so much of our infrastructure has moved to the cloud. If I'm an end user, I don't put firewalls and a like network intrusion detection system. That's cloud provider's problem. My problem is data. I need the same level of metrics. I need to know, is my pipeline reliable? Is my data quality good? Is my performance acceptable? How are they trending? Can I predict if something is going to go wrong? So all of that is at the data level, and that is my biggest asset. I, as an organization, I only care about data at this point. I don't really care about infrastructure. So in my opinion, data observability market should be at least as big as observability market, if not bigger. Igor?
okay. Very good.
Yeah, I 100% agree. I think to go back to why it's bigger and also how it's different, I'm also going to go back to my previous answer. Data is just so unique. Every company has their own data that they're tracking. There are very few similarities across data sets. Every company has their own models, has their own concepts, has their own information they're tracking in their own format. Some teams use SQL and fully normalized tables. Some companies take a big JSON blob and throw it into MongoDB. It's all data at the end of the day, and it all needs observability, and you still need to understand what it looks like and when it's performing in the way in ways that you don't expect, and then what are you going to do about it? And that's really what observability tries to help you solve for. And the reason data observability is different is because in software, the concepts across applications are very similar. You have your latency in your QPS, and you have your memory utilization, CPU utilization. Same, I can track the same metrics, and when those metrics go wrong, I know something's going wrong in my application, and then I can start working backwards. In data, there's so many things that can go wrong. A field goes missing, it goes null, it changes, the values in that field change. From an application perspective, normal software observability doesn't look at that. We don't look at API request response patterns in order to understand, did something change about the inner workings of that API? But we look at the QPS. But what if the QPS is the same, but the response from the server is actually different? Maybe you expect an email in your response, and you're getting something that's not an email, like it's a hash of some sort or a user UID, because the application developer changed something and it got broken. Software observability doesn't solve for that. Data observability has to, because once it's at the data layer, once you've now put this in the database and analysts or data consumers are looking at it, they need to know that it has changed. And describing that, the process of being able to look for that and describe it and track it and understand where it's coming from, what it's affecting, that makes data observability so much harder and such a more intractable problem at the generic level. And so a lot of the tooling and a lot of what we do at Bigeye is help build products that allow you to express that that broad space of observability that you want to track about any sort of data that you have. And that's the important part of it. And that's why it's so much harder. And that's why it's such a large market as well.
Yeah. And just to add to that, Ravit, imagine you have an infrastructure consisting of many applications, and an application crashes. If you've got proper, good systems in place, that application can auto heal and restart. There might be a blip from a user experience point of view, and now you're back to normal. But imagine now that the database crashes. You have no idea, did the transaction commit? Is the quality good? It's like, what is the state of that? So that's why data, anything that touches data is just constantly changing, gets more complicated than infrastructure or an application.
Okay, those are great points there. Thanks for that, Sanjeev. Thanks, Egor. Also, we have a few questions here from the audience, in kind of interesting questions to definitely pick those. One from Kent himself. Thanks for joining, Kent. It's nice to hear from you. Can you effectively do data engineering today without data ops or observability? Very interesting question.
I would say yes, but it depends at what scale, right? So for example, I at Bigeye, we set up Snowflake early. Obviously, we're a data shop. We care a lot about data. We had a team of 4 people, and we had a Snowflake instance, and we all knew what the data that was going in there. We didn't really have that much of it. We set up our pipelines. We went to Fivetran. We swiped our credit card. We moved the pipelines over, set up a couple of basic models in dbt, and started doing some product analytics. That's still data engineering. We're still building the pipelines. We're still getting the data from point A to point B. We didn't have observability on it. We didn't have a catalog, and we didn't have all this lineage information, but we didn't care at that point, because that wasn't the purpose of the data engineering. The purpose of the data engineering was to quickly drive some sort of business decision. Data ops and observability and all of this tooling is required once you need to scale that. Once you get to the point where you can't hold all this information in a person's head, and once you need to scale that out to the rest of the organization, and you find yourself answering the same questions, you find yourself running into the same problems over and over again that you want to track yourself, automate the tracking of, that's when you need a lot of this tooling. And so can you do it effectively to solve the business problem at hand? Yes, but what we found is teams scale out of that very, very quickly. And for two reasons. One is the data becomes very important to the business, in which case, let's say you're a financial, a fintech company, and the data is your lifeblood. You need accurate data in order to process, let's say, loan applications or whatever it is, right? Maybe you have a team of 10 people, but if your data is wrong or something goes or something's up with your data and it doesn't work, your business doesn't work. And that's a problem. Right. And so then you need to bring in the tooling. Or once you scale past tribal knowledge phase, then it becomes harder to do it effectively. So that, I think, at some scale, it's possible, but most companies get to beyond that point very, very quickly.
Yeah. I want to add to that, Igor, you're absolutely right. You don't need data ops or data observability. You can do data engineering without that. But the problem is that you are now relying on, you're praying and crossing your fingers that things don't break. And who will find out if things break? Maybe the CFO. And the CFO will now call you and say, that change you put certainly has broken my dashboard. Yeah. At that point in time, the IT team goes into a very reactive manner and they're firefighting. That's what you want to avoid. That's what data ops and data observability help you avoid. They put in this discipline, so you proper testing, like Igor said, your automation in place. You don't want to make the same mistakes, and you're trying to catch problems before they happen. It is a very common thing where IT will build something, and then the QA tester is a senior executive who's running the dashboard. You never want to be in that, because with that scenario, you are doing two things. You are eroding trust in your data team's capabilities, and you're eroding trust in the data quality. So that's why if you're doing anything serious and at large scale, data ops should be very much part of your day-to-day life.
Okay, pretty cool. Thanks for that question, Ken. Brought out a lot of insights. But at the same time, I have a question. Like, obviously, we're talking a lot around data observability. So what is the biggest gap that you see in data observability today? And how do you think it will be filled in the future? That's like kind of a question I'm sure a lot of people have. And because how do you see it evolving and going out loud there? Yeah.
Igor,
I can go, and I'm looking at some of the questions that folks are submitting in chat, and I'm looking at Aditi's question about what's full stack observability, and I think this is going to tie in very nicely here. The biggest gap is the focus of data observability has been on the consumer side of things. It's the data is now in the warehouse. It's in its final destination. It's in its final state, and there's something wrong with it. And now we need to look back and figure out what that is. Now, there's been obviously a lot of conversation about lineage is important for data observability. It's true. It's important to know where the data came from, what it could be affecting downstream, upstream. But the biggest gap that I see is this connect between that final state, that final destination of the data in the warehouse and upstream. How did it get there? What were the pipelines that ran it? What database did that data come from? If it's like I mentioned earlier, if it's internal data, there's probably some SQL Server or Oracle or Postgres or MySQL box sitting behind that, or Mongo, to the denormalized folks in the room, sitting behind that and storing the source of truth effectively that the application is using, that then gets moved over to the warehouse. So how do we catch these things earlier? How do we trace back to them? How do we know that maybe even going all the way up, a change in an application code caused changes to be changes in how the data is stored in the transactional layer, which then caused the pipeline to either break or do something unexpected, which then caused the analytics data to be broken. And that's really that full stack observability, and that's the really complex part, and that's where I think that biggest gap in where the industry is headed is how do we get that going? So, for example, at Bigeye, we have customers that collect data, run Bigeye both on their application database, a replica of it, as well as their analytics database, and they say, all right, we can catch things earlier in our application database. We can also test that the pipelines are moving things correctly and that the replica for the application looks the same as the warehouse data does. And if it doesn't, now we can start pinpointing things. Is it in the pipeline? Is it in the code? Is it upstream? And so that's where I think the biggest gap is, and where we're going to have to fill it as an industry.
Okay.
I see two gaps. The first gap I see is lack of awareness. There's a lot of education that needs to be done. I have published a few data observability documents, including evaluation criteria, frequently asked questions. Even then, people ask me, well, I'm not convinced. Do I really need it? Or I've built something in-house. I think it's good enough for me. What is data observability? So I think there's still a lot of education that needs to be done, and that's missing. That's, to me, problem number one. The second problem is that a lot of products in this space are relatively very new. This is not a very mature old space. So sometimes I'll see that what the users want will require more than one product, sometimes two or three, because a certain department may want data quality, another one may want to understand performance, another one may want to understand auditing of usage of data, which falls under security. The problem is that we are facing is that we have so many different products in our data and analytics ecosystem now. One department could be FTPing a file onto S3 and then using Redshift. Another department maybe using BigQuery or Snowflake, and so to with Collibra Alation as a data catalog. So basically, customers are saying, I want a single pane of glass. Imagine, you're driving a Tesla, and Tesla has 4 or 5 different cameras, and you're the driver, and there are 4 or 5 different windows open, left rear view mirror, right front. It's like, it's impossible. You get into a crash if you're watching 4 or 5 different dials. So how do you get this, signals from different places, condense it into, like remove the noise and have a consistent, dashboard that shows me this end-to-end observability is still not there yet. And I know we'll get there, but right now we have too many disparate tools.
Okay, those definitely, I like the Tesla example there. I think Sanjeev, you've explained it very well with that example, so thanks for that. Also, we have a few more questions coming here. Let's take first of all this amazing comment from Dustin here. We need to be more proactive and have a big eye on our data, which 100% makes sense. The question from Dustin is, where does the responsibility for data observability lie within an organization hierarchy? That's important.
Sanjeev made a comment a little bit earlier that I think addresses this fairly well. It's at the end of the day, the person who is going to be yelled at by the CFO when something looks wrong on their dashboard is going to be the data team, the data engineer, the VP of data, however large your organization is. That's what's going to happen. Really, the responsibility for observability, though, I think extends beyond data engineering. Sort of what we were talking about, full stack observability. A lot of data problems aren't caused by data engineering. Data engineering is just sort of the catch-all bucket of, well, we're the ones responsible for the pipelines, therefore people assume that we are the ones breaking the data. But it's not. Oftentimes it's upstream. So the software engineers, the third-party providers broke their contracts. Whatever that is there needs to be some way to expose that information back out to the business. So the responsibility seems to lie within the data team, and specifically the data engineering team, the data producers, as we would call them. But I don't think that that's particularly fair, especially being on the receiving end of this myself at Uber. I did not enjoy that. And a lot of my job was to point out, here is actually what's causing these problems. I'm not trying to break your data. I am simply moving it from point A to point B and making sure that everything's smooth and the pipelines are working. But if you're having problems with your analysis, it's because somebody changed code upstream, or Facebook didn't deliver the data yesterday. That's why your dashboard didn't refresh. But it's that it was my responsibility to surface that. Otherwise, at the end of the day, I'm the one who's getting yelled at and the one has to go and fix it.
Yeah.
Yeah. Well put.
Awesome. So obviously moving on, I have something around the lines where, obviously we've spoken a lot around data observability, around the person who's kind of responsible and other things, but also what about the benefits in the use cases of data observability? Where do you see it applied in? Do you have any thoughts on that? Maybe Sanjeev?
Yeah, I can rattle off a few, and then I'm sure Igor will have a few to add. So some benefits. So one is and I alluded to this, you go from being reactive to proactive if you have observability, because you can see the trend, you can plot the trend. This is the volume of data, or this is a seasonality. I see a pattern of usage, and all of a sudden there's a blip. So, I was expecting the curve to go smoothly up, but it dipped. So something is wrong. So I plotted my future state, and now I can do some analysis, what we call root cause analysis of that. So that's one. The second advantage is again, Igor alluded to this. I can do impact analysis. If the data producer, which could be a third party person, changed something, then I can very quickly see what will be the impact on my entire pipeline. So my data transformation, the reports. So if I don't have data observability, then I'll get there, because data catalog also have lineage, but it'll just take me longer to get there. So data observability helps me, reduce this time to detect a problem and time to repair a problem. So that's a huge use case. Then another big one that I want to add is FinOps. So this is a relatively newer use case where we are saying it's not enough to just look at quality of data, and
Right.
it's safe, but also the resource consumption. So if I see the resource consumption has gone up, then because I'm collecting that metadata, I can then take some sort of proactive action and stop that query before I get a huge bill. So those are a few benefits of having data observability.
Very nice. Egor?
Yeah, I think Sanjeev covered the vast majority of it. I think the macro point here is between the root cause analysis, the impact analysis. This is really about finding out the real cause of problems as well as the real impact of it. And I kind of want to go back to this people problem of teams assume that it's the data engineer's fault, the data team's fault that something's broken, and they are solely responsible for fixing it. And bringing this visibility into here is what's actually going on. Also, as a data consumer, here declare your expectations, so then you can tell us what you expect out of it. And when something goes wrong, you'll find out about it first. You don't have to be surprised by it. It's having this visibility across the organization about the state of your data that gives your organization trust in the data and the ability to actually do something with it, and sort moves that onus of the data's broken, something has to be done, away from this team is responsible for that to the organization now is aware of what the state is and they are aware of what is being done about it. And maybe the person doing something about it is the data engineering team, but maybe it's not. Maybe it's the marketing team that says, we updated our Facebook contract. We know that the data is going to be delayed because we're changing vendors, we're changing the APIs, whatever, we need some downtime, we're going to declare that up front. We're going to tell you that this is going to happen. We now know that the state of the data is going to look like this for a while. No surprises. No surprises within the organization about your data.
Okay.
And if it's done well, if both data ops and data observability are done well, a huge benefit. I've seen this is a real life example where this company used to take 6 months to release a new product. Can you imagine, like, the business has a need and the data engineering team says, we'll add it to our roadmap, it'll be a few months. Now they do releases within weeks. So that release cycle has increased tremendously.
Awesome. Those are interesting insight. Thanks for sharing those. We have another question here, but before we take any of those questions, obviously, I just wanted to remind our audience who've joined us late that Bigeye is giving away one cool swag. So we'll be announcing the winner, but what you need to do is obviously type in #Bigeye in the chat, and we'll be doing a cool raffle towards the end of the show. So stay tuned for that. All right, so let's take this one from Emmanuel. How do we assess if an organization needs a data observability platform? Where do we start? That's a very important question, I feel. What do you think, Egor?
If you're getting surprised by your data, then you need a data observability platform. Going back to the element of surprise within the organization, if your stakeholders are opening up reports, if they're going to run a query and they look at the results and they're saying, this isn't what I expect, I'm going to have to go dig into this, or I'm going to go ask someone in the business if this is what should be happening. Is there any problems? Anyone looking at this? You're probably going down the path. You're at the point where you should start having a data observability platform or a plan. Where you start really depends on your organization's needs and, again, the scale of it. I know this is going to sound like a selfish thing because I am the co-founder of Bigeye, but a lot of teams build things in-house first and then very quickly realize that doesn't scale. If you want to make sure that your data observability plan survives the next 6 months to a year, you probably just want to start looking at a tooling such as Bigeye for your data observability platform. Because what we've found in reality is people build their own in-house. They'll say, well, all we need to monitor are these pipelines and these properties of them. And that's it. That's all the data observability we need. 6 months later, they have a different use case. But now no one's working on that project anymore. And now they have to go find an engineer to work on the project and extend their data observability system. We have a team of 50 plus people working just on this problem. And we can bring a lot of these insights to organizations that don't want to dedicate the resources to it. And if it's not core value prop for your business, if it's not bringing money to your business, if it's not moving your business forward, you shouldn't be spending time on it. And so data observability is a large part of this for many companies, where this is a necessity, but it needs to just exist and just work. And so if you are interested in figuring out where to start, I'm personally happy to talk about it. You can reach out to us through our website and read about what we have, but we can definitely help you understand where you are and where you need to go.
Okay, that's pretty cool. What do you think about it, Sanjeev? Where have you heard about people saying that, okay, now we actually need data observability platform because our data is maybe too complex. We need to have it. We need to understand it much better.
Yeah, some of the points that Egor brought up, I put them under build versus buy. When you you should absolutely build stuff that is so custom that only your team needs it. But I don't think data observability falls in that. The more you build, the more technical debt you gather. And then as requirements change or use cases expand, now you're stuck just trying to maintain your in-house system. So I would not recommend that. And who should
Mm.
do data observability? It really depends, how much time you're spending trying to do firefighting. Slack messages, people complaining things are broken, or I cannot find this data. Is this the right quality of data? Did my pipeline run last night? People are asking
Mm.
those kind of questions. It's a clear indication you need data observability, because no one should be wasting their time asking these mundane questions. They should be working to what more can I do with my data, rather than very tactical questions. So that's a clear sign that data observability is needed. If you have a very small setup with a few data engineers, yeah, I wouldn't recommend it. But as you grow your department, your data engineering team, I think it's a good thing to have.
Okay, pretty cool. Thanks for that. Thanks for the question, Emmanuel. Kent mentioned here, exactly, do you want to be a software development shop or focus on your core competencies? So that
Good
makes
point.
a lot of sense.
Yeah.
Awesome. Also, coming back, obviously, we've heard about a lot also about the software observability. So what does that mean? Like, what do you guys think about that?
I mean, software observability is here to stay. It's not going anywhere. We use Datadog ourselves. We need to monitor our own applications. I think the interesting part about software observability at this point is, how do you connect all of the dots together? Software is complex. If you look at Datadog, they have, I think, tens of products at this point. Database monitoring, APM, metrics, custom things. All of this is now being collected, and the challenge now is presenting this, Sanjeev's point, single pane of glass. What is my application doing? Where is it struggling? And that should go all the way from API comes in, hits the database. Is the database query efficient? Did the API return in a reasonable amount of time? Did the data returned by the API make sense? I think this is actually a really interesting part of data observability versus software observability, and where the two could start blending is, are we actually returning the right data from our services to begin with? And can that be a leading indicator of problems with our data or with our software, or both? And so software observability are here to stay, but there's a lot of really interesting things that can still be built into it.
Yeah.
Okay. And Egor, just a follow-up question there. So what are the different types of data observability? That's kind of, obviously I've heard a lot around that, but would love to hear your thoughts on this one.
Yeah, it's interesting that people say there's different types of data observability. I think data observability is a concept. I think there are different approaches to data observability. Yeah. And this is where the end result, the end goal of data observability is always the same. It's bring more visibility about your data into your organization. Now, the question is, how do you actually get there? Now, at Bigeye here, what we're big proponents of is T-shaped monitoring. So you probably care about knowing a little bit about everything, but a lot about the few things that matter to you. So going back to our Uber example, even what we're seeing with our customers, you have thousands of tables in your warehouse. You're really only using 50 to 100 on them on a weekly basis, probably, most likely. Everything else is tables that somebody created and never came back to, stale pipelines, deprecated pipelines, like a V1 of something that now got replaced by V2, and you keep it running just in case you need to ever swap it out, but now it's been 6 months and it just sits there. It's important to know a little bit about that. Like, are the pipelines still running? Is the data still going into it? Is it on time? But then the 50 to 100 things you really care about, you probably really, really care about. Things like formats and things like, are there any shifts in the behavior of the data? Who cares about that? What needs to be done? Where is it coming from? So the end goal is the same. The question is, which side do you start approaching it from? the little bit about everything or the a lot about something. And at Bigeye, we try to enable both of those and help you find the things that you care about and understand how to actually monitor them in a way that helps your business avoid surprises about the things you care about.
Okay, interesting. What do you think about that, Sanjeev?
First of all, there is observability, even if we talk about just data and analytics, not the Datadog Splunk kind of infrastructure. Even at data and analytics, there are different types. For example, let me narrow down the list. There's ML ops, and machine learning ops is actually a very, very detailed thing. They look at so many machine learning parameters. So to me, that's not part of data ops. Then there is something called business observability, KPI observability. Again, I don't include it in data ops. Data observability. If I look at data observability, in my mind, it breaks down into two approaches. Some vendors are more focused on data quality, and some are more focused on data infrastructure and pipelines. So data quality ones are looking at the dimensions: duplicate, missing data, timeliness of data, accuracy of data. Data infrastructure people are more interested in compute, performance, and so on. So those to me are two different. But even when it comes to data quality, I see even that is now breaking up into two parts. There are some that are looking at the generation of data into the value of data, like what values are stored. So they're inspecting the packets. And then there are data quality observability tools that are looking at logs, query logs, application logs, and then doing that time series analysis. So that's how I see it.
Okay.
Igor, would you agree? It's kind of like there's a lot of different approaches I see that vendors are taking.
Yeah, that's right. I think 100%, Sanjeev, where you're mentioning about the approaches, I think there's a lot of approaches out there. Okay, one quick question that we had here from Dustin is, how do we get business stakeholders excited about data observability? That's interesting.
The story that we like to use is always, when was the last time you looked at a dashboard and it was broken or the data looked like the numbers looked wrong? And every single person is going to say last week, earlier this week, whatever it is. They're going to say, yeah, I remember, and I couldn't do anything, and we kind of wasted 15 minutes in a meeting discussing why the data is wrong. Like, you get them excited by saying, do you want to avoid situations like this? Do you want to save your time? Do you want to feel more confident in the data? Do you want to know about these problems ahead of time rather than being surprised by them? And most business stakeholders value their time, they value their energy, and they want to spend their time and energy on other things than, let me look at this dashboard and I don't trust the data, so I'm going to look at every single number and gut check it and make sure that it looks right. That showing them the path forward to a world where they don't have to, they can trust the data and they don't have to double check it all the time I would hope get them excited about having data observability in the organization.
Very cool. Dustin, Sanjeev, what do you think about it?
Yeah, I think the thrill of having an ability to do multiple releases within a month, to me, is a huge thing. It's like what used to take months, I can now, just keep
accomplishment
going.
out there.
Yeah, because CI/CD is part of this space. The bigger space of data observability and data ops, and I think that's pretty exciting.
Okay, that's nice. Moving forward, obviously, I know for a fact where, obviously, Igor, you've done a lot in this space for the community as well. So how is Bigeye's approach different and what is data stack observability? Can you also tell a little about, give us a little insight into that?
Yeah, and so I know there's a question here from Emmanuel as well. I'm not gonna I can talk about that as well in this answer around how does Bigeye differ from Monte Carlo. We've sort of been talking about other vendors, other approaches. So I can definitely talk more about the approach that Bigeye takes. And for us, it's all about flexibility and pushing the observability into as far upstream as it can go and as deep into the data as possible, and being able to scale that out and make that efficient. So for example, as I mentioned, we have customers that use Bigeye's Delta feature to say SQL Server versus Snowflake. Do they look the same? Or is our replication correct? Migrating from Snowflake to Databricks, from one warehouse to another, is my migration working as I expect? My very important table, let's say it's my orders table, is the distribution of my prices correct? Do I have negative prices? If I have negative prices, that's going to screw up my machine learning model, and that's going to be a problem for me. And so our goal at Bigeye is to help you express these things as quickly and efficiently as possible. Where I've mentioned a lot of other vendors start with that broad and shallow of a little bit about everything. Let's get freshness everywhere, let's get row counts everywhere, and then let's, if something's not fresh, let's figure out why it's not fresh, which pipeline caused it, and what happened. That helps you get part of the way, but a lot of what's important to you and important to your actual data products is that deep observability. It's that understanding that the data that you're using is conforming to what you expect. And being able to express that efficiently is something that's really important to us here at Bigeye. And we actually have a exciting release coming up later this week. I'm not going to spoil it, but it'll help do this at scale for a lot of data engineering teams and push it more towards tools that you're more familiar with and tools and more code-based rather than having to click through a UI. So stay on the lookout for that as well.
Okay, that's pretty cool. Looking forward to that one, Igor, 100%. Also, that brings me to another important question. If people want to actually learn more about the educational stuff that you guys are doing, I know for a fact that Bigeye has a lot of a lot of articles, but at the same time, you also have a lot of ebooks that are also, and maybe some guides that are coming up. So where can they go, reach out, learn more about it, Igor?
Yeah, our website's a great starting place. We have a whole resources section now. Our blog, we publish a lot of content on our blog, not just about Bigeye, but about the space and how people are approaching data reliability problems and how they're implementing their own. We have events and webinars, so sign up. We do a product demo about once a month or so. So you can sign up for our next product demo and see it in action and learn more about it that way. Also, I say this on every single show, and I mean it. Email me, igor@bigeye.com. I will respond to you, and I will gladly help answer your questions or put you in touch with the right folks on our team.
Okay, that's nice. Thanks for that, Igor. Okay, one quick question here from Yavin that I wanted to pick. How does Bigeye handle other external forces to govern data against, that is PII or GDPR issues, to prescribe a better decision against the business process model? Very interesting.
This is really interesting. This is a good question, Yavin. So a lot of times what we see with data that's considered sensitive is it's sensitive for it could be sensitive in one of two ways. So the first way is people just shouldn't be seeing it. Honestly, like for example, if emails are showing up in a field, you're already doing something wrong, for example. And in that case, what we help teams do is we help monitor those fields and say, do any of these look like emails? If anything here looks like an email, then our hashing mechanism's broken and our obfuscation mechanism's broken. We need to know about that early and go and fix it so that we can comply with all of the policies that we have. The other side to this is maybe it's okay to see this data, but you want to start marking it as sensitive and roll that further into your models, understand where that sensitive data is coming from in your application. So that's what Bigeye can help do, is understand where is it and where is it coming from and what does it look like, so then you can make better decisions about what to do with it. I'm not quite following the last part of this question to do better decisions against the business process model, but Yavin, if you could reach out to me on LinkedIn or email, I'd be happy to continue the discussion.
Awesome. But that was kind of interesting and helpful, Egor. So thanks for that. Also, one quick question to both of you, obviously. How do you see data observability in the next 2 to 3 years? And what are the major developments that you feel that will happen in this space?
So I see data observability becoming more accepted. I also see that I mentioned that there are different schools of thought on data observability and different approaches. So I see those coming together, because it'll be very hard for organizations to have piecemeal data observability. I see almost everybody is now introducing data observability. If you are a data catalog vendor, you have it now. Different cloud providers are starting to look into it. DBT is everybody now is looking into this. But what is going to happen is that there'll be a consolidation, a more cohesive single pane of glass kind of offering, rather than multiple different ones.
Yep.
Interesting. Egor, what do you think?
I agree with the single pane of glass. As a technologist, something that it gets me interested is, how do we even get there? Right now, the difficulty in getting there is every database, every data store, every ETL framework exposes its own set of concepts.
Correct.
There's no standard. Open Lineage, actually, I don't if you've heard of it, was a project around creating a standard around across pipelines and data sets and describing them in the same manner. That was a really interesting initiative. It was actually the company behind it was bought by DBT earlier this year. I think.
Astronomer.
Yeah, by Astronomer, right? Astronomer. That's right. And so now the interesting question is, what are we going to do with that? There is a lot of work around the standardization of how do we express these concepts? How do we map the concepts from the individual systems into one? What does an airflow pipeline? Does an airflow pipeline look like a Dagster pipeline? Look like a Matillion pipeline? How do we? What are the properties of all of those that we can track? This standardization has to happen in order for us to get to a single pane of glass, and I can guarantee you that every single data vendor right now has the same problem. It's go and connect to a bunch of these disparate sources, normalize all of the information they're providing you, and then expose that in the product. We struggle with it at Bigeye. I know everyone else struggles with it across the space. I'm really hoping for some standard to come out. I don't know if it's Open Lineage. I don't know if it's something else, but hopefully some major player adopts one big one. Maybe if Astronomer can really get Open Lineage embedded into the Airflow community and maybe even pushed back to the open source, into open source, and have an easy way to declare things around it, that might be that triggering point for us to say, here is how we describe data assets. And now that it's in every single Airflow pipeline and expressible, now everyone else has to start conforming back into it. And then it'll become a lot easier to build these single panes of glass. And then data observability becomes, how do we present that information? How quickly can we take action on it? And that's really the exciting product problem, not the integration side of things. So I'm really hoping that from a technology standpoint, we get there in the next couple of years, so we start answering these more interesting product and business questions.
Yeah, I want to end here by saying that data observability sounds like a misnomer. Igor, I don't know if you agree or not, because it sounds like you're observing the data, but observing the data is not that interesting. Why would you just observe the data? You need to observe the data, notify, alert if there's a problem, and the holy grail would be if you can automate some remediation, which is not going to be that easy, but at least have recommendations.
Yep.
So
Right.
don't leave people hanging and say, "Oh, here I found all these problems. Good luck." So there has to be some closure to that.
Yep.
That's very true. I agree. Awesome. Those were great points. Thanks a lot. It's also time for us to actually announce the winner of the swag. So let's go ahead. This is very cool raffle that we always do on our show. It's like for those obviously participating, but also joining the show, it's always a benefit. Here we go. For those who participated, all the best. Let's see who the winner is. So this is a cool raffle for those who put a hashtag. They actually put into the tool, and the winner is Sonia Kanwasara. Congratulations, you from YouTube. So you win a swag of Bigeye. Thank you very much, Bigeye, for providing that. One last question, actually, I wanted to take from Igor, from Dustin. And this is pretty interesting, and it has been asked a lot of times. I've heard a lot about it, but how would data observability fit into a broader data governance program? And that's something has been I've heard a lot about it. People talk a lot. So what are your thoughts about that, Igor?
Data observability on one hand, provides signals that you need in order to have a data governance program, and on the other hand, it takes information from your data governance program in order to provide you better signals. For example, if you already have your data subject matter experts who are curating data sets in a catalog and saying, this is where you go for sales data, this is what it looks like, this is what every column is going to give you. All of those things can be expressed in these sorts of data observability assertions. We expect this column to be positive. We expect this user ID column to always have a value and not be null. That can then flow back into your data observability platform and allow you to monitor for those things over time. And then when there are problems, alert you back through the rest of your governance program by saying, all right, hello there, sales data owner. One of these assertions was violated. The data observability tool found that there are nulls in your user ID. This is affecting the following things. Go reach out to somebody about it. Or maybe we are about to trigger this. We're about to just go drop all these records, like Sanjeev said, auto remediation. We're about to drop all these records. Are you okay with that? If you are, press yes. We're going to go clean it up. We're going to rerun our check. We're going to update your catalog. Everything's all golden. So I think it's part of a larger program, but the signals flow both ways, and it's an important part of a broader data governance program.
Okay, these are amazing questions. Thanks for that, and thanks for sharing those insights. Igor, Sanjeev, I think audience have definitely enjoyed this, and me being out there learning so much from you both. But one final question: if people want to reach out, I know Igor, you mentioned they can reach out to you on LinkedIn and also on email. But Sanjeev, if people want to reach out to you, learn more about different projects that you're doing, where can they reach out and learn more from you?
So the easiest way is if you go to my website, which is SanjMo.com,
Okay.
and you can post a question and I'll just trigger an email to me. I also have a YouTube channel called It Depends. So I have posted a few data observability videos on that. If you want to check it out, just have to do a Google search for It Depends SanjMo, and you'll see some of my videos.
Okay. I am just typing in your website here. And for those who want to reach out to Sanjeev, they can go out to his website and learn more from it. And also for all the resources that you might want to learn more about our data observability, Bigeye is your place. And Love the work what Bigeye is doing. Egor, thanks a lot for coming on and sharing these insights. I'm sure the community loves these insights. For those who obviously we had a lot of questions, but feel free to reach out to Egor or Sanjeev. I'm sure they'll be happy to help you.
Yes.
And thanks again for joining us. I know, Sanjeev, it's been a long day for you, so we'll let you rest and go to Big Data London tomorrow.
Yes.
And Egor, I will see you tomorrow. And thank you very much.
Yep.
All right, everyone.
Bye-bye.
Thanks, everyone.
Bye.